We hear all the time about the advances in AI. Like, it's just amazing how these systems are doing better and better on all these benchmarks. But it's hard to know, really, what that translates to. I mean, can they do real work, the kind of things that take, like, real time and effort?
Oh, I totally agree. Benchmark scores are interesting. They kind of show us what these systems are capable of. But they don't necessarily tell us the whole story about how close AI is to being able to tackle big, complicated projects that might take a human, days or even weeks to really focus on.
Right. And that's what made this new idea, this 50% task completion time horizon, such a fascinating way to think about it. It sounds a little jargony at first, but the basic concept is pretty straightforward. It's not just about passing a test, it's about figuring out how long a task would take a human to do, and then seeing does the AI have at least a 50-50 shot of completing it.
Exactly. It's about putting AI capabilities into terms that we can all wrap our heads around. Time. Instead of just these abstract scores, we can start thinking, okay, how long would it take me to do that? And can the AI do it in a comparable amount of time?
And there's this really cool study that we're diving into today that actually tries to put some numbers on this. They took a bunch of tasks and then they threw a whole lineup of cutting edge AI models at them to see what they could do. We actually have the research paper, and it's a really in-depth look at this whole thing.
It's a really interesting way to view the progress of AI, moving beyond just simple comparisons of better or worse
Yeah.
and actually trying to quantify how capable these systems are. And it uses how long it takes us humans to do those same tasks as a yardstick.
So for this deep dive, we're going to unpack this whole 50% task completion time horizon idea. See what it tells us about where AI is at right now, especially in areas like research and software engineering, things that I know a lot of you are working on out there. And we'll think about what this might mean for those really big, hairy projects that still seem like they need a human brain to get done.
That sounds like a good plan.
Yeah.
To really understand this time horizon, we first need to understand what kinds of tasks they use to test the AIs on.
Yeah, so it wasn't just any old task they grabbed. They had some very specific sets of challenges, right? Like HDAST, for example.
Yeah, HCAST. That stands for Human Calibrated Autonomy Software Tasks. It's a whole collection of 97 different software-related tasks. And the thing that's particularly relevant for your audience, I think, is that they vary a lot in difficulty. And how they measure difficulty was by looking at how long it would take a skilled professional to get them done. And we're talking about a range from about a minute to something like 30 hours. They covered a lot of ground, too. Cybersecurity, machine learning, just general software engineering problems, and even some reasoning tasks that go beyond just pure coding.
Wow, 30 hours. So if you're out there in software land, 30 hours is like, that's a serious chunk of time. Multiple days focused on one problem. That gives you a sense of the kind of complexity they were aiming for here. And then there was our bench.
That's right. Our rebench is a set of 7 machine learning research engineering tasks. And these are really challenging problems. They estimated each of those RE-bench tasks to take an expert human about 8 hours to complete.
Yeah.
So again, some pretty meaty problems that require a good bit of specialized knowledge. Think like debugging a super complex model or really tuning and optimizing a brand new training pipeline.
So we're talking like quick fixes all the way up to almost a full week of work just on a single problem. And then there was this software A set, software atomic actions. That sounds kind of different.
It is. SWA's a set of 66 short, really quick, single-step software development tasks. These tasks take less than a minute to complete, like from just a second all the way to around 30 seconds. And you might think, well, those are kind of insignificant compared to those really long ones. But they actually play a pretty important role here because these short tasks help measure the capabilities of some of those earlier AI models included in the study, models that probably couldn't even attempt the more complex HCST or R-bench tasks. So it gives us a way to see how much progress has been made, even from those early models.
Oh, that makes sense. Yeah, you need those simpler tasks to kind of see how far we've come, even if those older models weren't designed to tackle the really big problems. So how'd they actually figure out how long these tasks take humans? Was it just like a guesstimate?
No, they got some real data for this. To establish these human baselines, they worked with experienced professionals who had, on average, around 5 years of experience in their respective fields. And across all these task sets, they actually collected data from more than 800 human attempts. That adds up to something like 2,529 hours of work.
Oh, wow, that's a lot of data. That's a lot of time spent figuring this out. So they had real examples of how long it takes actual experts to do this stuff.
Yeah, exactly. They weren't just making it up. And to get a good estimate for each task, they used the geometric mean of all those successful completion times. The geometric mean is helpful because, sometimes people are really fast or really slow, and this kind of average helps balance out those extremes.
So they've got their tasks and they know how long they take humans. What was the next step? Just like unleash the AI on them.
Pretty much. They took these 13 different state-of-the-art AI models and ran them on all these tasks. These weren't just any random AIs. They were carefully chosen to represent a pretty big chunk of AI development, from back in 2019 all the way up to models that are just emerging now in early 2025. And when they looked at the results, they saw a pretty clear trend. As you might expect, over time, the newer models were better at finishing more of the tasks, which isn't surprising. But it's good to see it actually play out in the data.
Right, so not shocking, but important to confirm. And I remember reading that in general, they had a harder time with those tasks that took humans longer, right?
Yeah, that was a really key observation. The longer it took a human to complete a task, the lower the probability that these AI models could finish it. Makes sense, right? More complicated problems are harder for everyone, even AI.
So how do they go from all this, the AI success rates and the human time data and actually calculate this 50% time horizon metric? Sounds kind of complicated.
It does involve some fancy stats. They took inspiration from the way we analyze test results in education and psychology. They use something called logistic regression, which essentially models the relationship between how likely an AI is to successfully finish a task and how difficult that task is. And remember, difficulty is measured by how long it takes humans to complete it.
So logistic regression is all about like predicting whether something will happen or not. Like in this case, will the AI succeed or fail?
Yeah, exactly. And the whole point was to find that sweet spot, that specific human completion time, where their statistical model predicts a 50-50 chance of the AI succeeding. Imagine a graph. On one end, you have the easy task that AI gets right almost all the time. On the other end, you have the really hard ones where it almost always fails. The 50% time horizon is right in the middle where it has like an even shot at getting it right. They have a formula for this, but the main idea is to find that point where the odds are basically even.
Got it. So after crunching the numbers for all these different AI models, what did they find out about this 50% time horizon? What was the big takeaway?
The most interesting finding, and maybe a little alarming, is that this 50% time horizon is growing really, really fast. It's growing exponentially since 2019. In fact, their analysis suggests it's been basically doubling every 7 months. And you can actually see this trend pretty clearly in one of the figures in the paper.
A 7-month doubling time. So every 7 months, the length of the task that an AI has a 50% chance of completing is basically twice as long. That's that's pretty wild.
It is. It means AI is getting better at handling more and more complex things at a really accelerating pace.
Now, they also looked at an 80% time horizon, right? What did that tell us?
Yep. And what's interesting is they saw roughly the same doubling time, about 7 months for the 80% time horizon too. But the difference was that those 80% horizons were a lot shorter than the 50% horizons. For example, if an AI has a 50-50 shot at completing a 50-minute task, it might have an 80% chance of completing a 10-minute task.
So what does that difference between the 50% and 80% tell us?
Well, it suggests that while these AI models are getting good, sometimes even succeeding at pretty tough tasks, they're not always reliable on those longer ones. They might get lucky now and then, but consistent performance on those longer, trickier problems, that's still a work in progress.
Yeah, makes sense. Anyone can get lucky once, but being able to do it consistently, that's what matters for real work. So besides just looking at the numbers, did they dig into why this is happening? Like, what are the AIs getting better at that's pushing this time horizon out so fast?
They did. They looked at how the models performed and found a few key things that newer AIs seem to be way better at. One big one is their ability to use tools effectively. Recent models are much better at figuring out how to leverage external resources like code interpreters or even search engines to get the job done, which is kind of a big deal because that's how we humans do it, right? We use the tools at our disposal.
That's huge. Being able to find and use the right tools is so important for solving real problems. Problems that don't, like, come with all the information you need already packaged up nice and neat. What else?
Another thing is, they're better at learning from their mistakes. Earlier models, they would kind of keep repeating the same errors over and over. But these newer ones seem to be better at figuring out when they're going down a rabbit hole and trying something different. They even have data showing how these repeated errors are going down in the more advanced systems.
So they're not just blindly trying things over and over. They're actually like learning as they go. That's exciting. And I remember something about improvements in logical reasoning and how well they can write code too, right?
Oh, absolutely. Big improvements there. They're getting better at understanding the logic of a problem and then generating code that's actually accurate and useful. For your software folks out there, that's definitely something to keep an eye on.
So it sounds like things are improving across a lot of really important cognitive skills.
Uh-huh.
But were there things that even these really advanced models struggled with, like limitations that our listeners should be aware of?
Oh, yeah, for sure. One thing that kept coming up was that AI still has a hard time with things that are less structured, what they call messier tasks. Situations where there aren't clear instructions or the feedback isn't straightforward or the AI has to be more proactive about finding the information it needs. Like a complex research problem where it's not even clear what the right questions to ask are.
And that's so much of the real world, right? Especially in research, it's rare that things are all laid out for you like a textbook problem.
Exactly, which brings up a really important point. How much do these results from these specific tasks really tell us about how AI will perform in the real messy world that your listeners are working in? The researchers themselves called this out, this question of external validity.
And to look into this, they did a bunch of extra experiments, didn't they? Like one was with this thing called SWE bench verified, right?
That's right. They applied their methods to SWE Bench Verified, which is another benchmark that focuses on software engineering tasks and already has human time data. And what's interesting is that they found a similar pattern. The 50% time horizon was growing exponentially. But on SWE Bench, it was doubling even faster than what they saw with the main tasks they used in the study.
So faster progress on that specific benchmark. Why might that be?
Well, they think it might have to do with how the difficulty of the easier tasks in SWE Bench was rated. The way those were measured might have made it look like the AI was improving faster than it really was just on that particular set. It's a good reminder that the way we measure these things can really affect the results.
Good point. It's not just about the AI, it's about the yardstick we're using too. And then there was that whole analysis of messiness you mentioned earlier. How'd they go about measuring that and figuring out how it affected the AIs?
They took all those HTAST and RBench tasks, and they carefully rated them based on 16 different messiness factors. These were meant to capture those things that make real-world tasks so much harder than your typical clean benchmark problems. Things like, are there limited resources? Is the problem totally new? Is the environment changing? Is it hard to know if you're succeeding or failing? And so on.
16 different factors. Wow, that's a lot of ways to be messy. And when they factored in this messiness, what did they see?
No surprises here. Once they accounted for how long the task was, the AIs generally did worse on tasks that were messier. The messier the task, the lower their average success rate was. Which again points to the fact that current AI is still not great at dealing with the kind of open-ended, unstructured stuff that you run into all the time when you're doing research or building real software.
Right, because the real world is messy. But what about the rate of improvement? Was AI getting better at these messier tasks more slowly?
That's where it gets really interesting. Even though they weren't as good at the messy tasks overall, they didn't see a big difference in the rate of improvement between the less messy and more messy tasks. It seems like those core advancements in AI, better reasoning, better tool use, and so on, might be helping across the board, even if those messy problems are harder to start with. So it's not like they're hitting a wall specifically on those less structured tasks.
That's a good sign. It means that even if it's harder, the AIs are still getting better at those messier problems. And there was one more thing I wanted to ask about, the internal pull request experiments. That sounded like a really cool way to get a sense for how this plays out in real software development.
Yeah, that was a really interesting part of their work. They took a handful of real issues, recent issues from their own internal software development projects, and they compared how long it took their experienced internal developers to resolve those issues versus how long it took external contractors they hired to do the same thing.
And how much of a difference was there? I'm guessing the internal team was way faster since they already know the code base so well.
Oh yeah, it was a pretty big difference. The external contractors, they generally took somewhere between 5 and 18 times longer to fix those same problems compared to the internal folks who maintain that code. It just goes to show you how valuable it is to really know a system inside and out.
For sure, someone who knows the code base like the back of their hand is going to be a lot faster. So how did the AI compare? Did it perform more like the internal experts or the external contractors?
When they looked at how the AI performed on these real-world tasks and compared it to their predictions based on those HCST, SOAA, and R bench results, they found that the AI was more in line with the external contractors.
Interesting. So that suggests that this time horizon metric that they've come up with, it might be a better measure of how AI will perform when it doesn't have all that insider knowledge. Like it's more comparable to bringing in a new team member or working with someone from outside.
Exactly. It tells us that when we think about AI taking over tasks that humans do now, we need to keep in mind the level of specialized knowledge and experience that the human brings to the table.
Okay, so we've seen this really fast exponential growth in this time horizon on those benchmark tasks. What's it telling us about where AI might be headed? The study talks about extrapolating this trend forward, projecting it out, and specifically they talk about reaching a 1-month task completion horizon, which sounds like a huge leap.
It is a 1-month time horizon, and they're talking about like a
Yeah.
solid 167 working hours. It was interesting to them because it represents a substantial amount of work, enough to develop a big software application or even, potentially make some real scientific discoveries.
So based on that 7-month doubling time we've been talking about, when do they think AI might be able to handle those month-long tasks?
Their initial estimate, and they're very clear that this is just an estimate, suggests it could happen somewhere between late 2028 and early 2031. But they're also upfront about the uncertainty here. Even a small change in that doubling rate could change the timeline a lot.
Right, because exponential growth can be unpredictable like that.
Nice.
And I remember they talked about some of the challenges in predicting this far out too, right?
Yeah. They pointed out some big differences between their nice, controlled benchmark environments and the messy real world. Like in the benchmarks, scoring is automatic, and the AI doesn't have to interact with other agents. And resources are often, kind of unlimited, and it's all pretty static. So the benchmarks might be making things look easier than they are in reality.
And what about AI itself? I mean, the rate of progress, is that going to stay the same or could it speed up or slow down?
Well, they considered a few things. They said advances in the way we train AI to do these really complex tasks, that could speed things up. On the other hand, if we hit a limit in how much computing power we can throw at this, that could slow things down, although, new algorithms could help with that. And then there's the really wild card, the possibility that AI itself could start to automate a lot of the AI research and development process, which could, totally change the game and make progress happen way faster.
So lots of unknowns. It's an exciting time, but also a little scary. And they were also pretty upfront about the fact that this time horizon metric, it's not perfect, right?
Right. They're the first to say that the results depend on the specific tasks they used and on the expertise of those human baseliners. And measuring these super long time horizons, that gets tricky because it's hard to design those super complex tasks and find people to do them and collect all that data.
So we've gone pretty deep into this 50% task completion time horizon and all the implications. What's the main takeaway here for those of you listening who are out there in the trenches doing research or building software?
I think the main message is that AI is getting better at tackling really complex, time-consuming tasks, and it's happening fast. That's 7-month doubling time since 2019. That's significant.
Yeah, and if this trend keeps going, it could change a lot about the work you do. AI might be able to do things that now take weeks, even months of dedicated human effort.
That's the potential. But we also need to be realistic and remember the limitations of this work. The researchers themselves are very clear about that. We don't know for sure how well these results translate to the real world, and who knows, maybe the pace of progress will change. So it's good to be excited about the possibilities, but also to stay grounded and keep a critical eye on things.
So here's something to think about as we wrap up. Given what we've learned about how quickly AI is getting better at doing complex things, what kinds of research or software projects that take a lot of focused human effort right now, what could realistically become something AI can handle in the next few years? And what does that mean for your field? What are the big picture, strategic, and economic implications that we all need to be thinking about now?
Those are great questions. And if you're really interested in digging into the nitty-gritty, we definitely recommend checking out the full research paper. There's a lot more detail there about how they did this work and what they found.